Worksheet 10B, transverse shear stress. Each section below is subjected to a transverse shear stress force V. So they give us now have a shear force V here. And the question is two things. First, determine for each cross section. They give us the cross section, in this case rectangle. I call that a box beam. And the other one at the T shape, so I call that a T beam. So easy to refer later on. The transverse shear stress at the neutral axis and at point B. So neutral axis for each box beam or T beam. And then sketch the transverse shear stress distributions for both beams. So let one at a time. We need to first consider the box beam. So let's talk about the box beam, which cross section is a rectangle. And the question for A, determine the transverse shear stress at the neutral axis at point B. So the question we want to find out for A is what is tau at the neutral axis and what is tau at point B. And what equation we have for this one, we already know. Tau equal to VQ over IT. For those don't recall, go back to the note for the tau at here, transverse shear stress equation. So from that here, I have tau VQ over IT. Just go, V is already given. Just go ahead to find out Q, I, and T. So give what is given right now. V, in this case, we have problem with us 50 kips already given. I, for the box beam, can we find out the I? The area moment of inertia. Remember, it equal to 112 parallel time perpendicular quip divided by 12. All right. So the neutral axis with that beam, the neutral axis, we already know it will be, because rectangle, easy to find out, that's the centroid at the center of the rectangle, and the neutral axis go through here. That in neutral axis. So from that we can have the 112 of that we can plug in. It equal to basically BH cube over 12. So plug in. It equal to 112 B for 86 cube. So from that we have 72 inch 4. And we have the thickness or the width of the beam. In this case, as you can see, you have T actually here. For this, it equal to 4 inches. So that's what we have for information we have. Now go ahead to find out the first moment of outward area as the neutral axis and at the point B. So Q at neutral axis equal to equation equal to this area, outward area. Everyone see that? So it will be equal to y bar times that A apostrophe and that y bar from the neutral axis to the centroid of that red areas. So as you can see, equal to 1/2 of the height of the 3 inches. Okay, so that from here, neutral axis to the centroid of that red areas, and that the height of the beam equal to 6 inches, so half of that is 3, and it only half of that red, so it will be 1/2 of the 3 inches time the areas. So as you can see, the areas equal to the width times the height for that red component, so it will be equal to 3 half of the beam time 4, which is the width of the beam. So from that we can have equal to 18 unit inch cube. And to find out the tau at point B, we need to find out what is the first moment of outward area at point B. It equal to also y bar a apostrophe. So let me erase this one just to show you where to find out from B. So y bar and a apostrophe, we need to know where is the a apostrophe in this case from the point of interest, to outward area. So that is the area we are looking at. And the y bar is from neutral axis to the centroid of that blue shape that you have y bar for this. So from that we can have equal to y bar on that. We'll have 3, as you can see there, minus half of 1 inch, which is the point B to the outermost fiber, as you can see, right? So it will be y bar equal to 3, which is the whole, and you can see there from the neutral axis to the outermost fiber is 3 inches. So you have 3 minus half of 1 inch, that is the centroid, so it will be minus 1 inch divided by 2, that half of that to get y bar, time the areas. The area in this case, as you can see, it equal to a rectangle shape, and the width is 1 inches times 4 inches for the length of that rectangle, blue rectangle. So from that one here, it equal to 10 inch cube. So when you have all of that, we have V on that equation. V we know, Q we already found out, we have I, we have T. So we just go ahead to find out the T for the tau for the neutral axis. At the neutral axis equal to VQ over IT, so it equal to 50 kips times Q 18 divided by I, we have 72, T in this case 4, so that we have this one we have equal to 3.125 units is KSI, because all it keeps and inches. So that is the first answer we have. And then the next question is, what is the transverse shear stress at point B? So it equal to, of course, VQ at B equal to 10 divided by I, the same for that cross section, right? Remain unchanged. That is the area moment of inertia of that cross section. T at point B, also T also 4 inches. So we have 4. So from that it will be 1.736 KSI. And that is the answer for the second answer for part A of the box beam. And the question also want to be what sketch of the transverse shear stress distribution for both beams. So as we already know, Q is very parabolically throughout cross section, and tau it will be the same. It's the same thickness in this case. As you can see, T the same. So let's do the part B in here. Part B, we have the tau distribution. That's what the question asks for the box beam. So for tau distribution, let's draw the cross section. If we have a cross section, and in this case, just up here. So this, the vertical line, vertical blue line in there, so that I just show the projection of cross section. And for the distribution, as you can see at the neutral axis, and in this case, that is neutral axis. So that is center of the rectangles, and for the tau at the neutral axis, that it equal to 3.125. So you have that 3.125. So that point here, 3.125 KSI. And at point B, which is, let's put the on the direction in here. That what is 6 inches. And at point B is 1 inch from the top, as you can see there, and 1 inch from the top. So you have that point B. Point B here, 1 inch, and it's 1.736. So it's more than half of that middle neutral axis. So it's more than half. So it's somewhere there, more than half. So that point is 1.736 KSI. And this parabolic is maximum at the neutral axis and 0 at the outermost fiber. And we already know the Q in the worksheet A, Q for the outermost fiber. So you can see that in the distribution of this one is, my kid crying, as you can see, not sure what's going on. I'm sorry for that. We'll get out to see later on. So here, that is parabolic, and then this cross section is the same for the bottom, so it will be the same for the parabolic there. So this is the distribution of the shear stress. So with that, we do for the first part, which is the box beam, and the next video we will show how to do for the transverse shear stress and its distribution in the T-beam.